Okay, we're going to fool with the chi-squared now. There's two types. I'm not going to get into this. Excel doesn't do a good job on this, so I'll put in the reading how to do it. You pretty much have to calculate it by hand. But let's focus on this one, where you have some kind of observed quantity. You subtract the expected if they were all equal. Manipulate, divide it by the expected, square it, and calculate the chi-squared. What's the probability of that just being random chance? Okay. Oh, and while I'm thinking, let's use the degrees of freedom. Basically, this is how the things can move up or down or whatever, and this will calculate that. So in this case, our degrees of freedom for our chi-squared, I'm going to do Republican, Democrat, and Independents. And I just made up these numbers, all right? I got 2 rows, so row minus 1 is 1, 3 columns, 3 minus 1 is 2, so 1 times 2 is 2, so I got 2 degrees of freedom. Now what I'm going to do is, this is going to take a while, but I'm going to do some summing here. Go across the rows. And then I'm going to sum this one too. Oops. Okay, and then come across. I'm going to do this grand total too. This 279. I'm going to do that also, all right? So, what I want to do then is I'm going to make the expected column. Let me put that in bold. So I'm going to copy this over. Okay. Now what I'd expect, if all things were equal, there was no difference, I would expect some different number. And that number would be what? Out of Republicans, I would expect 81 out of 279 to be Republican. I want to multiply that by my total men. So I'm doing 49, or I'm doing 81 out of 279. That will give me my ratio of Republicans for the whole group. I want to multiply that by the total number of men. So I'd expect to get 48.48 men to say they're Republican, if they're the same as women. Now let's do the next one. Again, I'd have 81 out of 279. And I'd multiply that by my total number of women. I expect to have 32.51. Now if you notice, you add up these two here, right? It comes out to 81. Okay. Let's do the same for Democrat. And let's get the women. Women. Okay. Again, I check as it adds up to 105. Independents. 93. Oops. Equaling 3 divided by 279 times my total number of independents, 160, or times the total number of men. Okay, and I do the same for women. So what I've got now is I got my observed. This is what I actually saw. And if there was no difference, this is how the this chart would look. Okay, again, this is discrete, but we can do this. If the expected, it doesn't matter. So then I come down here, I'm going to do the chi test. Oops. Equal chi. Is that it right there? No, hold on. Chi-square test. So I'm going to type in my actual. I just take the 6 numbers that were in the actual, and it asks me for what I'd expect. And just close it off. So what I'm saying is the difference between men and women, there's a 90.9164313% chance that the difference between men and women is just a result of random variation. And that's the chi-squared. You can have as many columns over here, or rows, as you want. You have as many columns as you want. It'll calculate it for us.